Welcome to Chandra Max channel. Third B.Sc. Mathematics, Multiple Integrals and Applications of Vector Calculus, Semester 5, Paper 6b, Unit 3, Vector Differentiation. Unit 3, Vector Differentiation Definition. Derivative of a vector. Let f be a vector function with a domain S. Here S is called domain and R is called codomain. Here let f be a vector function with a domain S and T belongs to S or A element belongs to S is said to be differentiable at A. If limit T tends to A, f of t minus f of a by t minus a exists. This limit is called derivative of f at the point A. It is denoted by f dash of a or df by dt at t equal to a. Therefore, f dash of a equal to limit t tends to a f of t minus f of a by t minus a. This formula is also called as a first principle in Intermax 1b differentiation chapter. Note, in general differentiation in Intermax 1b, derivative of uv means derivative of product of two functions. This can also be written as uv whole dash equal to u into derivative of v plus v into derivative of u equal to u into v dash plus v into u dash. Derivative of u by v, division of two functions with the derivative, or u by v whole dash equal to v into derivative of u minus u into derivative of v by v square, v into u dash minus u into v dash by v square. Now we can apply these general differentiation formula to vector functions. Properties of vector differentiation. Let f, g, h be three differentiable vector functions at t. Then derivative of f plus g equal to df by dt plus dg by dt. Derivative of f dot g. This is in the form of uv with a dot product in vectors f dot dg by dt plus g dot df by dt. Here we apply general differentiation formula uv. Derivative of f cross g. Here also we are using a derivative of uv formula with the cross product f cross dg by dt plus g cross df by dt. Derivative of box of f, g, h. So first derivative f, the remaining are fixed. Derivative of f means df by dt g h with box. So box of df by dt g h. Next derivative of g. So f dg by dt h. So box of f dg by dt h plus box of f g dh by dt. Next one, derivative of f cross g cross h. This g cross h can be taken as v. So here also we can apply derivative of uv with cross product. F cross derivative of derivative of g cross h plus g cross h into derivative of f. Again, derivative of g cross h is like this. So f cross g cross dh by dt plus h cross dg by dt plus g cross h into means g cross h cross df by dt. So we have to apply the formulas of derivatives in vector differentiation. If r bar equal to e power minus t into I bar plus log of t square plus 1 into j bar minus tan t into k bar, then find dr by dt, d square r by dt square, modulus of dr by dt, modulus of d square r bar by dt square, dr by dt cross d square r by dt square at t equal to 0. Solution. Given that r bar equal to e power minus t into I plus log of t square plus 1 into j minus tan t into k, differentiating 1 with respect to t. So d by dt of r bar equal to I into derivative of e power minus t plus j into derivative of log of t square plus 1 minus k into derivative of tan t dr bar by dt equal to I derivative of e power minus t. Since derivative of e power x is e power x, so derivative of e power minus t is also derivative of e power minus t is also e power minus t into derivative of minus t plus j. This can be taken as x log x. Derivative of log x is 1 by x. So derivative of log of t square plus 1 is also 1 by t square plus 1 into derivative of t square plus 1 minus k. Derivative of tan t secant square t e power minus t I. Derivative of minus t is minus 1 plus j into 1 by t square plus 1. Derivative of t square is 2t plus derivative of 1 is 0, means constant derivative is 0, minus secant square t into k bar. So finally derivative of r bar means dr bar by dt equal to minus e power minus t I plus 2t by t square plus 1 into j minus secant square t k. This is dr bar by dt. This can be taken as equation 2. This implies dr bar by dt at t equal to 0. Means put t equal to 0 in this dr by dt. Something power 0, 1. So minus I, this is 0, minus secant 0 is 1. So finally minus I minus k. dr by dt with the modulus equal to square root of I quotient whole square plus j quotient whole square plus k quotient whole square, root 1 plus 1, root 2. So dr by dt at t equal to 0 and modulus of dr bar by dt. Now d square r bar by dt square. For that again differentiating this dr by dt. Again differentiating 2 means derivative of dr by dt equal to minus I derivative of e power minus t plus j derivative of 2t by t square plus 1 minus k derivative of secant square t. This is d square r bar by dt square minus I derivative of e power minus t is e power minus t into derivative of minus t plus j. This is in the form of u by v. So we can apply u by v formula. V into derivative of u minus u into derivative of u into derivative of v by v square minus k. This is in the form of x power n. So derivative of x power n equal to n into x power n minus 1. Derivative of x power n is n into x power n minus 1. Here we are applying this formula. So n into secant t whole power 2 minus 1 into derivative of secant t minus I e power minus t Derivative of minus t is minus 1 plus j t square plus 1. Derivative of 2t is 2 into derivative of t 1 minus 2t derivative of t square 2t plus derivative of 1 0 by t square plus 1 whole square minus k into 2 into secant t derivative of secant t into tan t. This is equal to minus into minus plus e power minus t I plus 2t square plus 2 minus 4t square by t square plus 1 whole square j bar minus 2 secant square t tan t k bar. Finally, e power minus t I bar plus 2 minus 2t square minus 4t square minus 2t square by t square plus 1 whole square into j minus 2 secant square t into tan t k bar. This is d square r by dt square. So d square r by dt square at t equal to 0 is e power 0 means put t equal to 0 in d square r by dt square e power 0 into I plus two minus 0 by 0 plus 1 whole square minus 2 secant square 0 into tan 0 into k. This is equal to something power 0 1 I plus 2j minus 2 secant 0 is 1 tan 0 is 0. This is equal to I plus 2j 0 into something 0. This is d square r by dt square at t equal to 0. D square r by dt square with modulus equal to square root of I quotient whole square plus j quotient whole square plus k quotient whole square 1 plus 4 root 5. In this way we can calculate a second derivative also. Now cross product of first derivative and second derivative. So dr by dt cross d square r by dt square at t equal to 0. So dr by dt at t equal to 0 is minus I minus j minus k. D square r by dt square at t equal to 0 is I plus 2j. For this cross product can be taken as in the dead form I, j, k. Here first vector minus 1, j 0, k value minus 1. Next second vector 1, 2, quotient of k is 0. Plus minus plus. Delete this first row and first column. 0 minus 1 2 0 minus j. Delete this first row and second column. Minus 1 1 0 plus k. Delete this first row and third column. Minus 1 0 1 2 like this. 0 minus 2 minus j 0 minus 1 plus k minus 2 minus 0 multiplication. I 0 plus 2 minus j 0 plus 1 plus k minus 2 minus 0. So 2i minus j minus 2k. థ్యాంక్ యూ స్టూడెంట్స్. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే లైక్ చేయండి, మీ ఫ్రెండ్స్కి షేర్ చేయండి, సబ్స్క్రైబ్ చేసుకోండి. థ్యాంక్ యూ.